So welcome to our video for today. So in this session, we are going to have the lesson derivative of trigonometric functions and logarithmic functions. So yung ating learning objectives is that at the end of the topic, you will be able to first recall trigonometric identities and logarithmic properties in differentiation. Because of course, you should know the ruling on the properties of logarithm as well as the trigonometric identities for us to be able to deal with the differentiation process. And then another learning objective is that we will have to memorize derivative formulas on trigonometric functions and logarithmic functions. So dapat maging familiar tayo with the formula so that you can execute smoothly the functions. Okay, and then from that we are going to apply the derivative formulas on trigonometric functions and logarithmic functions. So all will be packaged to simplified answers to some functions involving trigonometric and logarithmic. So let me start with the formulas itself. So these are general formulas involving trigonometric functions. So basically we have 6. So yung sa sine x, the derivative of sine x is just equal to cosine x. And then the derivative of cosine x will be equal to negative sine x. And para sa tangent, that is just equal to the squared of the second function of that x. And then for the cosecant function, that will be equal to negative cosine x times cotangent x. And then for the secant, that will just be equal to secant x tangent x. And then for the cotangent, that is just equal to negative cosecant squared x. So yun yung general rule, but we need also to incorporate here the chain rule, that if we are going to derive yung sine u or the sine u in terms of x, so first execute cosine u x and then of course differentiate the inner term. Now if this inner term should be differentiated again, then gawin natin, ano? So kaya nga tinawag na chain rule, because as we derive u, there are terms inside that u that could be derived again and again. So it is a rule of chain of differentiation. Okay, so all of the chain rule will be applied to the mentioned formula of the 6 trigonometric functions. So with that, without much ado, let us have examples. Okay, so here are some set of examples 1 to 7 for number 1. So simply we have to derive y with respect to x. We're going to find dy over dx, and we should know the derivation of sine function. So yung derivation ng sine function is just equal to cosine x. And we should note that there will be, so perhaps we can just express this into u para ma-emphasize natin yung chain rule dito. While we execute this cosine u, we should also execute the green. And the green refers to the chain rule, or just derive the inner term. So in this case, our u here is actually 5x, no? So yung u mo dito is equal to 5x. So if we are going to derive that one, du over dx is just equal to a constant 5. So if we are going to derive this now, no, we derive sine of 5x, that will just be equal to cosine 5x. Okay, and of course indicate natin yung du over dx, which is derived as 5. So our dy over dx is simply equal to 5 cosine of 5x. So this is the answer. And then moving on to the second problem. So in here we have y in terms of t. So we are going to execute dy over dt. So we derive this with respect to t. So dy over dt for y equal to the derivative of cotangent is simply equal to negative cosecant squared u, and don't forget d over dx here. So we execute this derivation. So cotangent 40 will become negative cosecant squared of 40 multiplied by our derivation of 40, which is equal to 4. So finally, the answer dy over dt is equal to negative 4 cosecant squared of 40. So this must be the answer. Okay, for number 3, we're going to find the derivation of x with respect to u. So we say dx over du, and then the derivation of tangent of this function 2u. And the derivation of tangent is just equal to secant squared u multiplied by du over dx. So we execute now. So we have secant squared of 2u. Then we derive this inner term, and that would simply equate to 2. Therefore, our answer is equal to 2 secant squared of 2u. So this is the answer for the third problem. So moving on to the fourth, we have x with respect to theta. So x becomes dx over d theta, and then we derive cotangent of the function 3 theta. The derivation of cotangent of the function is simply equal to negative cosine squared u times, of course, du over dx. So with this must be equal to cosine squared 3 theta times the derivative of this inner term, that will be equal to 3, and therefore we will have this answer is equal to negative 3 cosecant squared 3 theta. Okay, so moving on to the fifth problem, just the same. We're going to execute the formula for this function, secant, in terms of theta. No? So this becomes dr over d theta, and then execute derivative of secant u, which is simply equal to secant u tangent u, and then yung du over dx. So we do that in here. We have, kopyahin mo lang yon, dagdagan mo lang ng tangent function, and then this one. That would be equal to 6. So finally, dr over d theta is equal to 6 secant 6 theta tangent 6 of theta. And this will be the answer for the fifth problem. So moving on to the sixth problem, we have secant squared x minus tangent squared x. So in this case, it involves here now a second degree curves. Kung mapapansin nyo, second degree curve. So remember, if we have a power greater than 1, of course, we will just have to execute ito, power formula. U raised to n is equal to n u n minus 1 du over dx. So meaning, we'll just bring down this. Una muna itong y prime. Baba mo yung 2 dito. Kopyahin mo, bawasan ng isa. Okay, and then derive the inner portion as an application of the chain rule. Ito, du over dx. And what will be secant x is actually secant u tangent of u. And by the way, hindi dyan nagtatapos because we still have to apply chain rule here. And the differential of u with respect to u is simply equal to 1. By the way, yung variable pala natin is simply equal to x. So that is the first term. So moving on, dito naman tayo sa second term, we also apply that one. We have a power formula. Again, indicate yung sign dito, ibaba mo yung 2. Ibaba yung 2. Then, copy tangent of x. Subtract 1 from the exponent. And then derive tangent of x. So, tangent of x should be equal to secant squared x. Ito, tangent of x is equal to secant squared. Then, applying the chain rule, differential of x is simply equal to 1. So, if we are going to simplify this now, the first term would yield to 2 times secant squared x because yun secant squared raised to 1 na lang yan. Multiplied sa isang secant x, magiging secant squared x. And of course, we place this tangent of x minus 2. Isa na lang din yung tangent of x because nabawasan ng isa yan. Times secant of x squared. So, interestingly, kitang-kita dito that 2 secant squared x tangent of x is the same to the negative. A negative version lang yan. So, meaning, this will just cancel. Hence, our y prime is equal to 0. So, this must be the answer for number 6. Okay, so with that 6 problems, nakompleto na natin lahat ng formulas. So, we are going to expand our derivation on some various ruling in derivation. So, in number 7, we have here a product rule. Ito, product rule, u times b. Anong gagawin natin dito? So, alam naman natin na u dv plus v du for this. So, we should note that we derive the equation x in terms of t here. So, we are going to find dx all over dt. Say dx all over dt. Okay, copy the first term. Derive the second term. What is the derivation of sine? Is cosine 2 theta. So, huwag mong pakalimutan yung apelido na du over dx or the chain rule. Just we derive this 2t here with respect to t, that will just be equal to 2. So, that is u dv. And then, the second term is v du. So, plus copy the second term. And of course, derive the first term. So, yan power rule lang. So, we bring down 2 here. Copy t and then derive t with respect to t. That will just be equal to 1. So, therefore, we have here 2t squared cosine 2t plus 2t sine of 2t. So, I think this will be our answer. Say this is dx over dt. So, moving on to the next set of problem. So, in here, we need also to refer to our trigonometric identities. And I have sent you a supplemental video on this regarding the derivation of trigonometric functions or identities using super hexagon. So just go over with that video so that you do not need to memorize so many trigonometric identities. You can just derive it by the super hexagon following some rules that was introduced on that video. So ito na. So number 8, we have a product rule. This is the multiplication of cosine and cotangent. So of course, we just execute to, u dv plus v du, no? Okay, so let's do it. We derive this r with respect to theta. So yung r becomes dr over d theta. Copy the first term. Then derive the second term. Anong derivation ng cotangent? Yan just equal to negative cosecant squared u. And of course, wag nating kakalimutan yung du over dx. So we do that. Negative cosecant squared theta times 1. That is for the first term. For the second term, we have v du. Copy cotangent of theta and then derive cosine theta. So anong derivation ng cosine? So the derivation of cosine u is simply negative sine u times, of course, du over dx. So we do that again. Negative sine of theta times d theta all over d theta, that equate to 1. So we simplify, and this would be the first term. The second term would just yield to negative, no? So we have that cotangent theta times sine of theta. So we wanted also to simplify by applying trigonometric identities here. So notice that cotangent theta should equate to cosine all over sine. So palitan mo lang yan ng cosine all over sine. So sine will be just cancelled. And then, kung titignan natin, negative cosine is common. Kaya pwede na nating ilabas yan. Hence, we have this cosecant squared theta plus 1. Hence, we consider that as our answer. Okay, for number 9, there is a proving solution here to support this answer, no? Because sometimes in problems, especially when you have choices, secant tangent yung expression mo, and then yung pagpipilian mo in terms of sine and cosine. So we really need to be capable of expressing other terms with particular trigonometric identities. So with this, let us first execute the derivation formula, and then we will inject some of trigonometric identities. So una muna, dz over dt, the derivation of z with respect to t. At yung derivation ng secant is just copy secant and then i-add mo lang to, secant 3t, ano? The chain rule suggests na may 3 dito, no? And then derive tangent 3t becomes secant squared 3t. At yung apelido niya, d over dx, is 3. So in here, we just simplify and then use some identities. So perhaps kung sine over cosine yan, we will just have to use identities involving sine and cosine. So we know that secant is just the reciprocal of cosine theta, no? Ito, we can just easily derive it by superhexagon. Just as introduced dun sa supplemental video na binigay ko. And then tangent, it can be written as sine theta all over cosine of theta. So we just apply this now. Yung secant 3t mo magiging 1 over cosine 3t. And perhaps we can already reflect here the constant na 3 dito. No? And then for the tangent 3t, ano lang yan, sine over cosine. Then minus 3 times, anong secant? 1 over cosine. Kaya lang magkakaroon lang ng squared yan because this is squared. Parang ganyan lang yan, parang ganyan. Secant 3t squared. So if you're going to substitute 1 over cosine dyan, magiging 1 over cosine squared 3t. So simple as that. So basically, magkakaroon tayo ng the same LCD cosine squared 3t, ano? Kasi ito, mag-multiply yan dito, cosine times cosine, cosine squared 3t, the same as this. So the indication of that is that we can just directly subtract the terms under it. So finally, we will come up with the same answer. Okay, so that's for number 9. So for number 10, we are going to prove that if W is equal to 4 cosine squared 1 of y, show that dW over dy is equal to negative 2 sine squared y. So my technique here is first you derive before you substitute identities, or you may substitute the identities first and then derive. So depende sa diskarte nyo. So what I'm trying to point out here is walang iisang solution dito. So actually kanya-kanyang diskarte yan to arrive with the correct answer or the proof of the answer by your solution. So yung technique ko again, uunahin ko muna yung derivation before I substitute some identities. So here, this is a derivation of cosine. At the same time, u raised to n yan. And of course, let us not forget this one. At yung derivation ng cosine is negative sine u times du over dx. So, as simple as that. So, remember, yung 1/2 dito, part ng angle ng cosine. So, let us now execute. We have dw over dy. Ito, u raised to n. Ang exponent natin is 2. Bring down 2. That will be multiplied to 4. Becomes 8. Just copy the function. Bawas ng isa. And then derive the inner part. The inner part is cosine. So, magiging sine 1/2 of y yan. Okay, yung derivation of cosine is negative sine 1/2 of y. Again, derive mo yung inner term as a chain rule. Simply, that will be just equal to 1/2, ano? So, we now simplify terms here. So, all in all, magiging negative yan. Yung 8 divided by 2, that will be equal to negative 4. So, it will just yield to negative 4 cosine 1/2 y and sine of 1/2 y. So, we can express this in y over 2 so that we can perceive that this is a half angle, ano? So, it is just a half angle. So, what we do here is to apply what are those half angles. At ito yung mga formula ng half angle. So, what is next? So, if you notice, if we're going to apply cosine dito, no? Or sine man lang, in terms of square root yan. So, meaning, magiging komplikado yung equation mo if you're going to substitute this directly into this. So, what we do is to, of course, siguro pwede nating isimplify yung sine dito. And then, we can express it through tangent. So, that yung tangent, hubad yan. Meaning, wala siyang square root. Okay? So, what is the identity for sine in terms of tangent? So, remember that tangent theta is equal to sine over cosine. Hence, sine theta is equal to cosine tangent. So, palitan ko lang yon, cosine tangent. So, just maintain that one and then notice here na yung cosine magko-combine doon. So, by the way, wala pala tayong denominator dito, no? So, it must be a product supposedly. So, therefore, here, nag-combine na yun, naging squared na. Essential yung squared kasi just to eliminate our square root here on the identities later on. At yung tangent, naiwan naman na tangent yan. So that if you're going to substitute now the identity for half angle, so this one will be the identity dito. Okay, wala nang half angle dito. Kung titignan natin, we just substitute this cosine a over 2. So, your a here is y. So, yan, square root of 1 plus cosine a raised to y over 2. And since cosine is naka-square dyan, we just square that 1. So tangent y over 2 will just be replaced to 1 minus cosine y all over sine of y. Ito. So what will happen now? Ito, tanggal na yung square root. So that negative 4 will be directly divided by 2. Becomes 2. And then that will become, yan, maintain lang yun. So if we're going to multiply, get the product of this becomes negative 2 times 1 minus cosine squared y all over sine of y. And then remember that this identity, by superhexagon, we can see that the sum of the square of sine and cosine is equal to 1. So meaning, this must be a significant identity for this. So that we can simplify sine na magiging ganyan. So makakancel yung isa. Okay, so therefore, we'll come up with this answer. Negative 2 sine of y. So by the way, I have just mistaken on the copying of the answer dito. So supposedly this is negative 2 sine of y. So dw over dy is equal to negative 2 sine of y. So that is how to do it. So again, it depends on what will be your strategy. Either if you start to derive first and then substitute the identity, or use the identity first before deriving. So it does not matter as long as you arrive with the correct answer. So that's it for the first set of the examples, and I think you must have to be having a seat work for your practice. So thank you and good day.